Welcome back to Djji Tutorials. Today we are covering solving general triangles. Solving triangles using SSS, SAS, SSA, AAS, and ASA involves using specific rules to determine if two triangles are congruent or similar. SSS, or side-side-side, requires all three sides of one triangle to be equal to the corresponding sides of another. SAS, which stands for side-angle-side, requires two sides and the included angle of one triangle to be equal to the corresponding parts of another. SSA, that's side-side angle, and AAS, or angle-angle-side, are a bit more complex, since they can lead to multiple possible triangles in some cases. This is known as the ambiguous case. To prove triangles congruent, you need to show that corresponding parts, sides and angles of the triangles are congruent. Angle-side angle, or ASA, is a congruence postulate for triangles. It states that if two angles and the included side, meaning the side between those two angles, of one triangle are congruent to the corresponding two angles and included side of another triangle, then the two triangles are congruent. Side-side-side, or SSS, means that if all three sides of one triangle are congruent to the corresponding three sides of another triangle, then the triangles are congruent. For example, if triangle ABC has sides AB equal to DE, BC equal to EF, and AC equal to DF, then triangle ABC is congruent to triangle DEF. Side-angle-side, or SAS, says that if two sides and the included angle, the angle between those two sides, of one triangle are congruent to the corresponding two sides and included angle of another triangle, the triangles are congruent. For example, if triangle ABC has sides AB equal to DE, BC equal to EF, and the included angle B equal to the included angle E, then triangle ABC is congruent to triangle DF. Proof by drawing: if you draw two triangles with the same two sides and the included angle, there is only one way to complete the triangle and the two triangles will be identical. In simpler terms, if you know two sides and the angle between them are the same in two triangles, you can be sure the triangles are exactly the same. So, let's talk about side-side angle, or SSA. This term describes a scenario in triangle geometry where the lengths of two sides and the measure of one angle, the one that's not between the two sides, are given. Now here's the thing: unlike the side-angle-side, or SAS, congruence theorem, SSA is generally not a proof of congruence. That's because there can actually be multiple triangles that satisfy the SSA criteria. For example, imagine you have two triangles where you know the lengths of two sides are equal, and you also know that one angle, the one not between those sides, is the same in both triangles. It's possible that two completely different triangles could be drawn that satisfy these conditions. To solve for the other parts of an SSA triangle, you would typically use the law of sines. This law relates the ratio of a side of a triangle to the sine of its opposite angle. But, the SSA case can be ambiguous, meaning there might be two possible solutions for the third angle, or the missing side. That's why SSA is not always considered a sufficient congruence rule. Next up is the angle-angle-side, or AAS theorem. This theorem states that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the two triangles are congruent. In simpler terms, if you know two angles and one side that's not between those angles in one triangle, and you can find the same corresponding parts in another triangle, then the triangles are identical. Here are a few key points about AAS. First, you need two pairs of angles that have the same measure in both triangles. Second, the side you're checking isn't between the two given angles in either triangle. And finally, if all these conditions are met, the two triangles are congruent, meaning they have the same shape and size. Okay, so imagine two triangles. You know that two angles in one triangle are both 45 degrees and 60 degrees, and the side opposite the 60-degree angle is 5 centimeters long. Now, if you find another triangle where two angles are also 45 and 60 degrees, and the side opposite the 60-degree angle is also 5 centimeters, then the two triangles are congruent by AAS. Alright, let's talk about angle-side angle, or ASA. If two angles and the included side, which is the side between those two angles, of one triangle are congruent to the corresponding two angles and included side of another triangle, the triangles are congruent. For example, if triangle ABC has angles A equal to D, B equal to E, and the included side AB equal to DE, then triangle ABC is congruent to triangle DEF. So, ASA congruence means that if you have two triangles and you know that two angles in one triangle are equal to two angles in the other triangle, and the side between those two angles is also equal, then the two triangles are identical or congruent. Alright, so the order angle side angle is actually crucial here. The side has to be the one that's between the two angles, not just any side at all. For example, imagine you have two triangles. You know that angle A equals angle X, angle B equals angle Y, and the side AB equals side XY. Since AB is the side between angle A and angle B, and XY is the side between angle X and angle Y, and the other angles and sides are equal, then, yeah, the triangles are congruent. So ASA can actually be proven using the angle sum property of a triangle, which says that the three angles in a triangle always add up to 180 degrees, and also the side angle side, or SAS, congruence theorem. In real-world applications, ASA is a really useful tool for proving that two triangles are congruent, which can then be used to prove other geometric relationships. Now let's take a look at the law of cosinus, and then, we'll isolate cosine A, cosine B, and cosine C. Alright, so the law of cosinus states that for any triangle with sides A, B, and C, and angles A, B, and C opposite those sides, the following relationships hold. A squared equals B squared plus C squared minus 2BC times the cosine of A, B squared equals A squared plus C squared minus 2AC times the cosine of B, and C squared equals A squared plus B squared minus 2AB times the cosine of C. To isolate cos A, cos B, and cos C in the law of cosines, you rearrange the standard form of the equation to express the cosine of each angle in terms of the sides of the triangle. Basically, you isolate the cosine term, rearrange it, and then divide both sides by the appropriate term. So, to isolate cos A, you start with the first equation, A squared equals B squared plus C squared minus 2BC times the cosine of A. Next, you rearrange to get the cosine term alone, so 2BC cos A equals B squared plus C squared minus A squared. And then you divide both sides by 2BC, which gives you cos A equals B squared plus C squared minus A squared all over 2BC. Alright, so to isolate cosine B, let's start with the second equation. B squared equals A squared plus C squared minus 2AC times cosine B. Now rearrange it to get 2AC cosine B equals A squared plus C squared minus B squared. Then just divide by 2AC and you'll get cosine B equals A squared plus C squared minus B squared, all over 2AC. And finally, to isolate cosine C, we'll start with the third equation. C squared equals A squared plus B squared minus 2AB times cosine C. Rearranging gives us 2AB cosine C equals A squared plus B squared minus C squared. Now divide by 2AB, and you have cosine C equals A squared plus B squared minus C squared divided by 2AB. So, just to sum up the isolated formulas, we have cosine A equals B squared plus C squared minus A squared all over 2BC, cosine B equals A squared plus C squared minus B squared over 2AC, and cosine C equals A squared plus B squared minus C squared divided by 2AB. Thank you for joining us today, and I really hope you found this video useful. Please don't forget to share it with your classmates. See you in the next session.